Okay, I started recording this session. So yesterday we were discussing about pig introduction, and we have seen how to load the data, how to how to read the data from HDFS, how to read the data from Hive also, and how to load the data back to HDFS. So let me launch pig here. So we will see few more operations that we do here, like while reading data from structured or unstructured or semi-structured. So we deal with structure now, and in this demonstration we will also see some semi-structured data processing. And unstructured data, yes, we have some logs, LinkedIn logs. We will try to do that, extracting few information from that log that I'll be sending you today. So you can also just look at the log data and then see. Yeah. So yesterday we were using Hcatalog, right? So now I launched it directly, so we cannot access any Hive table. So if you want to work with any Hive table, so Hcatalog we need to have, because it is a kind of a meta store tool. So let's see, we loaded the data and then dump the data, but we didn't store back to any table, right? We will just complete that activity and then proceed with next operations. Okay. So to do that, yep, I have to use again one more terminal, and then pig hyphen use catalog. And we have seen yesterday also how to run from a pig script. Okay, I didn't note that particular syntax here, right? So to launch pig script, you have to use pig hyphen x and then map reduce, then name of the script, name of the script name dot pig if you give, so you can run those scripts. And if you want to run in local mode, same thing, hyphen x local pig script local dot pig. So these two commands we use to run the file pig script composed in a .pig extension file. So we know what is MapReduce and what is local. So if you want to work with the Hadoop system and Hadoop file system, you have to launch pig in MapReduce mode. If you want to work with local machine local files, you can use pig-x local. That is one thing. Yeah. Yes, it launched. So we will try to read a table, the same table we know here. So this particular statement load and then table name, Hive table name. So table name is prefixed with schema name KP database and using this particular driver. So hcatl loader. So if I execute this, the statement will run. Yeah, and now the data will be available. So now you can see dump A. Okay, before it gets completes. So now to store the data back, we know, right? When you are loading data into a relation, that relation is available only to that particular session. If you close the session means the data will be lost. I mean, you will be not able to recall or recover the particular relation. So before you exit, you always store it into HDFS or any Hive table. So since we are dealing with Hive table, so to store back the data, so you can see here, store. Now in our case, we have defined relation name as a that's all. Store A into some table, okay, KP database dot, then I can give this final u underscore user. I'll keep it like this. Using, if you see the driver, this is different driver, hcat storer, that is hcat loader, this is hcat storer, to store the data back to a Hive table. Let's see, I don't have the table created in this particular database with this name. Let's see whether it will create it or it will throw an error. Yeah, you can see the data has been displayed over here. Where are we working? This is Hcatalog, right? Okay, this is Hcatalog, but still maybe I have launched from here, so it is displaying the data. Okay, let's run this itself. So it looks like it is not expecting anything because it received metastore information. Okay, paste it. Sorry. Yeah. So here no need to define any relation, just store A into KB database, that is a final table, and then using this storer. Let's see. Yeah, it is saying that database is not sorry, table is not found. So you can do one thing. So we know how to execute a query, right? Without launching Hive script. So without launching this client mode, you can directly use Hive-E, and then you can see create table, okay, KP database dot final underscore u underscore user, like, you can give like operator. Okay, so create a table KP database dot final u underscore user, like u underscore user, but you have to specify the schema. Okay, this will create the table for you. Let's this execute. Yeah, now table not found u underscore user. Really? U underscore user should be there, right? Okay, let me execute this, or else let me launch it to Hive. I missed this, that is the reason. It is base, so that's why spell mistake. So this is something like this statement will create a table. If you specify like, means the entire metadata of this particular user it will use, and then it will create. It's a kind of a copy command, but it will not copy the data. It will copy the only metadata like table structure. Okay, so yeah, now the table has been created, and you can use show tables command, or else we will just load the data and then see. If you want to test it whether the data is available or not, let's see here. select a star from. So the expectation is that we will not have any records because we haven't loaded data to this particular table, and we will rerun this command. So which is loading data. This particular year is the relation name. So we are storing that particular information into this table. Now you see time taken and there is no data. Just give an OK command. Okay. So we will rerun this again after executing this command. It is running map reducer. Every time it will launch map reducers. Note that. So it start with mapper and then followed by reducer. So it combines both. Yeah, it says that successfully read the data and from this table and successfully stored the data in this, including bytes. You can see some other information also. Yeah, so now that is not burden for us. Now let's go and hit this query, and now we will see the data. So this is what we'll read the data, we load the data, and you can transform the data in between. So using pig script, you can also transform your data, depends upon your business requirements. You may transform, you may cleanse it, you may aggregate it. So that's how in real time it works. You see the data is available. So we just read the data and loaded the data to a Hive table. So this is how it works with respect to Hcatalog. Okay, guys.
Yes, Raja.
Yeah. So now we will look at some other operations that we have here in pig, and then we will just get to know what kind of commands or what kind of syntax that we use to process the data. First we will proceed with the structured data, then we will also discuss about semi-structured data today's session, and we will try to read the JSON data and then load normal data, load the normal data which is of like rows and columns to a JSON file, and then we'll see how output appears. And that is one thing. And semi-structured data once complete, we will proceed with unstructured data, but I'll be not doing that exercise. I'll just forward it to you. We will just find out some way to get the data from the log. So now I will run the two commands. I will load u data and u user data. So this particular u data, we have seen movie data we have, and user data also has the user information like his name, age, and occupation, and other stuff, zip code. And this one is having user ID, item ID, rating, and then timestamp. So it is delimited with the tab and it is delimited with the pipe symbol. So remember always, if you are not giving a proper delimiter, so it will load as a null values. So pig storage is something that we know. So it is a kind of a instruction to specify what kind of delimiter we are using, and this is used to load the structured files, especially text files. Okay, so now we have other storages also. We will discuss in this session what are all the other storages that we have. So let me run these two. Sorry. Okay, let's dump u underscore data. Let's see. And when you're working with two terminals, remember those relations will be available to that particular terminal only. You cannot expect to retrieve the same relation in the any other terminal. So
Yeah.
terminal is something that what I'm working here. This is terminal. Command line you can also say. So in real time, mostly you will be working with this kind of UI only, guys. You will not get the what I'm looking at the background like Cloudera thing, go to file system and all. You will not see. Even this particular file also you cannot open. If you want to store some files also you can store, but visibility will be like VI or more command you will use. So keep getting touch with that Linux machine commands also. So that
So
will be
you say it
useful.
will be more like putty, right?
Yeah, exactly. More like putty. Yeah, so now I'll be loading the other file. Okay, so it also loaded. Good. So now we will see grouping first. So what I want to do is in the particular u underscore data, I wanted to group it by item ID, and then I have to verify average of rating. So with respect to that particular item ID. So the syntax is first you need to use group u data that some relation is equal to group what you want to, I mean which relation you want to group it. So the name of the relation, then followed by, and then which column you want to group it. So this is a syntax in order to group. Okay, so now let's go here. So before to that, guys, I want to explain one more thing. Describe. So describe, if you see u underscore user, let's see how it looks like with the output of describe. You see here, so the output of describe is something that u user is the name of the whatever relation, and you see here user ID, age, gender, occupation, zip code. So it stores the metadata information. So if you want to look at each level, you can do that. So if you run now this group command, let's see. I'm running group command. So here also you can inspect the that particular relation. Okay, group u data. When you give this, now you see that. So this is the relation name and group int. So the grouping is performed based on integer, and whatever the u data it has, it will come everything. So the output of this particular group data also in the same way, like first it will be having a group item, then these all element will come in that particular bag. So now see, this is the bag. So if you see that flower bracket, this is one bag contains tuple, and this is one more bag, this is a main bag. So inside this bag, this is a sub bag. Okay, so now we'll list out the data using dump command and see how it
So
looks like.
instead of just displaying the data using group bys in previous sessions, we can actually take that subset and use it elsewhere, storing it in a variable, right?
Yes.
Okay, that's great.
Yeah, so now dump group data, dump group u data. Okay, means display. Dump means display. Store is used to load the data and save it in physical location. You see here, every time it is creating a jar file, guys. This is what I want to show you. But to do something with Java, now what is the work you need to do? You know, you have to open your Java uh, IDE like Eclipse or any other tool. You have to code it few lines to read the data and to process the data, and then you have to compile the code, generate the class file, and generate the jar file. This process, I mean, this much process involved when you are dealing with really Java. So this way I can say that a lot of time, our time saved when you are dealing with pig. So pig, it behind the scene it also creates map reducers only. But when we are communicating with pig, it is very pretty straightforward, since pig has its own Latin, its own commands. So just need to understand how to apply those, that's all. So no need to write lengthy Java code. So what they say, I mean what they uh, claim in their web page. So when you are writing something to achieve using Java, if you are writing 100 lines of code, here you can just achieve it five lines of code, 5-10 lines of code. But we need to get that grip, like all commands needs to be learned. Okay, so now you see here the data has been grouped. So for this particular 1 to 17 item, these three records are available. So when you're grouping like this, so it fetches all the data. So if you think that this is a tuple only, end of the day it is a tuple, this is the item id, and you see here there are three tuples surrounded by a bag. So this is one tuple, this is one tuple, this is one tuple, but entire tuple is surrounded by a bag. Okay, so that's how it forms when you are dealing with pig relations and grouping. It works like this. So now I want to calculate, based on this item id, I want to calculate a rating. So rating is the third column. So now how you can apply is, you see here this is little tricky. So you have to use for each command for each group u data. So this is the latest relation that we used. For each group data, generate u data dot item. See, u data is something that it is not the group data, this is earlier relation. Okay, so to generate a grouping, you have to give syntax like this. For each, you have to repeat this for each, okay, and generate on this particular group only. You're asking to generate u dot item id comma average of u data rating. So you are not directly specifying anything on the this particular group data. You just grouped, and that's all. And you are not doing anything here. So you are using for each, which means like for each element you generate this combination you're asking. So now what will happen, the data has been grouped like this, right? So this particular relation it will go, and what it will say, it understands anyway this particular combination formed by using u data only, and it will know this is u dot rating, this is the u dot, sorry, u underscore data dot item id, and this is the rating. So we are asking the relation, you see here, you are asking the relation to generate this combination item id comma average of u data rating. So here two relations involved, though we are working with group data, but when you are generating group by information, we again work with the original relation. Clear, guys?
Yes, Raj.
A little confused, but unless you practice on
Yeah,
your own,
getting it slowly, but yeah, I'm getting it.
yeah, but it is very simple. Okay, definitely you will get it when you do hands-on. Yeah. Okay, so now let's dump the relation a. Generate is a keyword, don't confuse here. So generate is a keyword, and we are forming a combination like item id. You can use even max, min, sum of, you can use any other aggregations also. To do aggregations, this is the syntax. We formed group only here, group by u data. Using this command we just formed the group, but when we are doing aggregations, then we follow this syntax. Let's see, it is taking some time. Yeah, now you see for this particular 1217, so the rating, average rating is 3.333. So that's how the data has been aggregated, but still you could see that three times it is, so three values are available. So to reduce that also we have operations, we'll see later. Yeah, so now we aggregated this, we have aggregated this. Now item id and then rating, average rating, right? Let's describe this. Describe a, I think. Now you see item id double, item id double. So if you want to set some name to this, you can use as, okay, avg underscore rating, you can give like this, okay, for the reference column. So now I will execute this describe again. Now you see here, so a is the relation name, item id comma average rating, so this is an integer value, this is a double. Okay, so that's how it formed a new relation name a. So now next we will see the same relation describe a when we execute this dump a. So we got this data. So now I would like to see only the rating which is greater than or equal to 3. Okay, so for that we use filter command. So how to apply filter? So this how. So anyway we need to define relation name equal to, then filter a. So a is the name of the relation that we derived in previous step. So filter a by, we have to give the keyword by what, which column? So average underscore rating greater than 3. So here we have given a name called average rating, right? So we have given avg underscore rating. So the same naming convention we use, and then we filter the data. Okay, now the data has been filtered out. Dump b, we'll see dump b. It's still running. Since we are working on single node, it will take time. Otherwise, if you are going for real time environment where you will have some 17 nodes or 80 nodes, even sometimes I see some projects are having 300 nodes also. So in that case, you will process the data very quickly. So it won't take this much time. You can see that the URL to track the job. So this is the job. Let's click on this. What you will see, let's go to that and then, okay, this meeting will end in 10 minutes. Upgrade now. Okay, no problem. Where it went. Huh. Okay, now you see the data has been filtered out and we are able to display only the rating greater than 3. So we have applied first group by on a regular relation, and then on top of it we made average, and then on top of it we done it filtered. Okay, clear guys?
Yes, Raja. And like, so just curious, what actually those links mean? Actually, where does that link actually take
Link,
you?
okay, link is something that a job tracker. So for every every job you will see one URL kind of thing, so resource manager, so how much time it took and all. So let's see in the next time when I launch it, or else let's see whether I can get the information now.
Is it like something like a
Job tracker
log,
kind of thing, yeah. Yeah,
logger or something?
yeah, let's see whether it is still have any information or not. We will go to log and then see. This is the information that you will see. So when it is started, how many map reducers successful. Okay, you see the state. Okay, submitted when, started when, finished when, how much time it took. So when you are running, when it is in progress also, you will see this as a progress in progress like that. This is what
Okay.
I've been explaining like a resource manager with tracker kind of thing. So job tracker, so how it is working. This is particular job ID. So every time you create anything or when you run, so job ID will get created. Okay.
Yes. Okay. Thank you.
Okay.
Thank you.
Yeah, no problem. So now what we will see, we will see one more concept. For that, I have downloaded some data from internet. So the data is something that. Okay, let me go to the data set, simple data set. We see now co-group. Okay, let's finish it. Remaining time is 7 seconds. Okay, 7 minutes. Inside this movie. Okay, so what I have the information here, one is employee.txt and other one is student details. Yeah, so now if you see here the age and I'll explain here what is the column structure. So student details contains ID, first name, last name, age, and then phone, city. And employee details contains ID, name, age, city group, city. That's all. So now what our intention is to see how co-group works. Co-group is something that you can group two different relations with same kind of a column name. For example, if you see age is common between these two, so you can do grouping of that particular relations using in a single statement. That's what co-group. So let's run this and then see. So we loaded the data to student details and we load the data to employee details relation. Okay, so now we have two relations. So now when you want to group it, these two relations, because these two different relations and with different structure itself, but the common column is age and you wanted to group it. So both relations. So now this is a syntax. Co-group student details by age, comma, employee details by age. So let's group it. Okay, now grouping has been done. Let's dump co-group. Just type some cog and then give the tab button. It will come automatically since it is available to that particular terminal. You see again one more URL has been created. Now you can see copy link address and then put it over here. Now you see 007, earlier 006, something wrong. Oh, maybe after completion of this it will get executed or what, not sure. Okay, cloud era.
That is giving the cloud era port like 1820 and all. I think the link paste here is having different port. Yeah.
Correct. By mistake I paste in another one. This is the actual URL for this. Now you see this.
I think it's loaded.
You see the status is running and the total
Yeah.
maps completed 2, total reduces 1, and let's see it's a default job name. Okay, now we'll go here and then see. Yeah, it ran. So now if you refresh this,
it says it's success or succeeded. You see, completed.
Yeah.
So now we'll go back here. Now, if you see here, 21, 22, 23. So it is a age we grouped by, and relations. If you see, the first relation is from these two. You see two bags are created here. Two bags, square bracket started here and ended here. This is one bag, and this is another bag for employee data. So we have group two. So one is from employee.txt and other one is from student.txt. So this is how you can group two relations. For that we will use COGROUP. This is a feature that available in Pig. Okay, clear guys?
Yes, Raj, I'm good.
Okay, Kalpana, any questions from your side?
No, Raja.
No problem, don't hesitate, Kalpana, you can ask.
No.
Okay, I'll stop the session and then I'll restart it. Okay, it is supposed to end it. Okay, don't want to
Okay.
in the middle. Okay,
Okay.
please join back guys. Okay, yeah.